All right. This is happy 22. 2022, I guess not year 22. We are talking about the sine and cosine curves, and we are going to graph sine and cosine curves. But you guys kind of already did this, so I made you like do that little exploration. So see if you can remember for this first graph what the sine of x curve looked like. If you need to look back at your chart, you can. And see for the second one if you can remember what the cosine curve looks like. And just do like a quick little sketch. Let's make some markings on our x-axis here so we're all kind of consistent though, okay? Let's say that this is going up by pi over 2's. So this would be pi over 2, this would be pi, this would be 2 pi. This would be negative pi, this would be negative 2 pi. On our y-axis, let's count up by halves. Let's say this is 1 and negative 1. And then same thing for this curve. Now you guys all did this perfectly because I checked and I gave you points.
Perfectly.
Perfectly? Did I say that word? Perfectly? Perfectly. Okay. I'm going to give you 1 minute. If you need to look back at your chart, you can. Do your best to kind of sketch the characteristics of the sine curve and the cosine curve. In the meantime, I'm going to pull up the unit circle for reference. Okay. For your sine curve, you should have something that passes through the origin, or we can kind of think it like kind of starts at the origin, and it crosses your x-axis at like all those like multiples of pi. All right, and then exactly halfway it went up here at to 1, down here at -1, something like this. And I said make it curvy. And then, so you guys did that with taking the values from the unit circle, and then I asked you like, what do you think the other side looks like? And it just kind of like repeats that pattern, like so. Okay, we'll talk about why all those points exist in a second, but that's what you got for sine. For cosine, this one was a little bit, it was the same exact like shape, it just looked like it was shifted over a little bit. So this one like kind of started up here at 1, and this time at all my multiples of pi were the mins and maxes. So then it crossed here, min, crossed, max. Look kind of something like that. And then continued in that same fashion where it crossed at all these like multiples of pi over 2. Not all multiples, just like the odd multiples. And you had like these mins and maxes here. All right, so that's just a recap of what you guys already did. We are going to break down kind of each basic sine and cosine curve, all their characteristics. There's some new vocab. And then we're going to eventually be able to graph like something like this. Like that.
I have no idea. Bro, what?
It's not.
That's illegal.
It's more intimidating. It looks more intimidating than it is.
That doesn't exist. You're tricking us.
Okay. So here's my new notes. We'll talk about this basic sine curve.
Thanks.
So I mentioned that when we write our sine curve, and you might want to like write it off to the side here. I just don't have any room on my slides. But this is y equals the sine of x, where my inputs are the angles. The inputs are the angles. Now you guys noticed that like it kind of had that repeating pattern. So we call that like periodic, or sometimes like cyclic is another word, because it performs like one full cycle and then that just repeats and repeats and repeats and repeats. So the sine curve, it's kind of like special characteristic. All right, so I kind of like screenshotted just like a part of a coordinate plane. So what we're going to do is we're going to count up by pi's over 4s, but we're only going to mark every like pi over 2. So pi over 2, pi. So I'm just basically counting like each tick mark in fours. 1 fourths, 2 fourths, 3 fourths, 4 fourths. 3 pi over 2, 2 pi. Let's keep going. 5 pi over 2, 3 pi, 7 pi over 2, 4 pi. Let's do the same on the left side of the y-axis, on the negative side. So negative pi over 2, negative pi, negative 3 pi over 2, and we'll just go to negative 2 pi. So because my inputs are angles, and we use radians for this, we're going to put our x-axis in terms of angles, in terms of radians, okay? Because that's what I'm inputting into my function. That's my independent variable here. And then I'm taking the sine of all these angles in radians. So I actually have some handy-dandy graph paper that you guys can have. You guys over here. That already has, oh yeah, look at that.
Oh yeah.
That already has like the coordinate plane labeled in terms of radians. So if you want to take some of that before you leave, you can for like your homework. So, but it's really easy to sketch too, like on normal grid paper. I actually think it might be easier to do it on your own because then you can kind of manipulate the x-axis a little bit to fit your curve. So the sine curve, I'm going to do this one in, started at the origin, and then as I just mentioned, it basically like crossed at every multiple of pi, where it had like an x-intercept. And the reason why is because if you think of your unit circle, at every multiple of pi, starting with 0, pi, 2 pi, 3 pi, 4 pi, what does sine always have a value of? 0, right? Always has a value of 0. So it's going to have an x-intercept, or a value of 0, at every multiple of pi, no matter if I'm going in the positive direction or in the negative direction. It's always going to have x-intercepts at those multiples of pi until we do some transformations, but the basic sine curve does. And then I talked about halfway between those, you should have like mins and maxes. So on my y-axis, count up by half, so call this 1 and this -1 just to space it out a little bit. I said halfway between, you had like a max up here at 1, a min down here at -1, at pi over 2, 3 pi over 2, and then it just continues in this pattern because it's what we call periodic. It repeats. Okay, so go ahead, draw on your mins and maxes. Why do we have those points? Well, let's look at this. At pi over 2, what's my sine value? 1. Okay, 3 pi over 2, down here at -1, and then it just keeps repeating. At another pi over 2, 1. Another pi over 2, -1. It just keeps repeating. You can go around and around the unit circle. You can go this way, or you can go this way. So I could do negative pi over 2, which is the same as 3 pi over 2. It's down here at -1. Negative 3 pi over 2 is up here at pi over 2. That's +1. And it just repeats. And the reason why it's curvy, because you guys all plotted those points, is because, you have values in between these that are like square root of 3 over 2. That's like 0.866. You have like these values kind of like up here. So make that curvy as best you can. Yes, Max?
So with 4 pi on the right side,
Yes.
Would that be the next one? Like would it be over 2 spots?
It's like you kind
next
of
dot up top.
messed
or-
her up.
Oh, did I mess it up a little bit? Sorry.
I mean,
I was just making sure that.
That should be an x-intercept.
Okay.
I don't know why I drew that in there. There. And I kind of missed it on my curve. All right, now, why does my curve never go any lower than -1 or any higher than 1? Why is like my range here just between -1 and 1?
wait,
Think of the unit circle.
number.
Because
It's
it's
farthest
all
distance away.
on both.
Yeah, I mean, that's basically right. If you're thinking about the y values, can we ever have a y value on our unit circle that's higher than 1?
No.
No, that's like the
No.
max.
Yeah.
Can it ever go like lower than -1?
Ain't going to.
No, that's the lowest y value on my unit circle. That's what the sign is. Okay, good. Now, here's some new vocab for you. So that's basically like why the sine curve exists. Now, you guys went through and like did all the plotting behind this. So I always like students to do that so you can kind of like conceptually understand why it looks like this, just based off the unit circle. My domain for a sine curve is all real numbers, because going on and left and to the right, I can take the sine of any angle I want to. We know that now. Before pre-calc, we've only been able to take like the sine of angles that were like in a right triangle, right? Because all you knew for sine, cosine, and tangent was right triangle trig. But now we talk about how we can position it on a coordinate plane, how we can have like negative angle measures, all that stuff. So there's no angle that you like couldn't take the sine of. The range I just mentioned, this only ranges between -1 and 1 because of what we just talked about. So let's use integral notation there, including -1 and 1 because I do have those mins and maxes there. All right, here's some new vocab. The amplitude is basically like the distance between the middle of your graph and the highest point. So maybe I should talk about like midline first, actually. Let's do that, midline. So right now with the basic sine curve, the midline is the x-axis. And just kind of dash it in. We call this the midline. This will always be a characteristic of your sine curve where you can kind of like split it in half, and it's very symmetrical, like above and below. Do you see how if I were to like slice it, it would like go like right through the middle of my curve? So my midline here is the x-axis, which is y equals 0. Okay, we call that the midline. The midline can move. It's not always going to be on the x-axis. We probably won't get to any of those today. So the amplitude, this kind of tells you like how tall your graph is. But the weird thing is it's only measured from the midline to a max. Like this right here we call the amplitude. We don't like say like from the min to the max. We say from the midline to a max is my amplitude. So yes, I think when you said that, this does have an amplitude of 1. Okay. So then a really important characteristic, because this is what we call like periodic, because it has this repeating pattern, we call the length of one cycle a period. Okay? So the most basic way to look at it is that it starts here at 0, and you can think of your unit circle. You guys started at 0, and you did all of like those angles until you got to 2 pi, and then you start over. So from here to here, that's like one cycle, and then it just repeats. See that? Same thing here. It would just repeat. So the length of that cycle, the length of one cycle, we call a period. So this right here would be the period. So for the basic sine curve, how long is that cycle? 2 pi. And it makes sense from our unit circle, because after 2 pi radians, it's just going to keep repeating. Do another 2 pi, then we're at 4 pi. That's going to keep repeating. So that length right there, the period, is 2 pi. All right. What else I want you guys to write next to your period is this little inequality here. So this is this is kind of like a method to help you find the period every time. And this, when you set it up like this, will tell you where your curve like starts and where your, I shouldn't say curve, where your cycle starts and where it ends. Okay, so write that in your notes. From 0 to 2 pi for the basic sine curve. Yes, sir?
Would it be the same thing if like the period was flipped? Like if it starts going negative first and then it ends up positive?
Like you do it like this?
Yeah.
If this length So that's like a reflection. That's actually the curve y equals negative sine of x. You just reflect it. It would do that. If that length is still 2 pi, if one cycle is still 2 pi, it still has a period of 2 pi. Amplitude is still positive 1.
Okay.
Yep. We'll look at some of those. So looking here for my sine curve, I have x-intercepts at every multiple of pi. Okay, so we could like list out a couple. We see negative 2 pi, negative pi, 0, pi, 2 pi, yada, yada, yada. Multiples of pi. So that's kind of one difference between the sine and the cosine curve. Cosine has x-intercepts elsewhere, and we'll tackle that in a second. Here's this big like difference. How I like distinguish between the sine and the cosine curve is the y-intercept. Because I think of the sine curve as it starts at an intercept, or it starts at 0, and it ends at a 0. So the nice thing about graphing these two, as I just showed you, like some of the equations look pretty intimidating, but there's lots of patterns, just like the unit circle. There's lots of patterns. Obviously, if it's one cycle, it's going to start and finish in the same spot. So if it starts here at 0, it's going to end at a 0, and then it has a lot of like halfway characteristics. So like for the sine curve, this will always hold true, even if I stretch or shrink this or shift it around. It'll always have this midline. It'll always start at an intercept, end at an intercept. Halfway, it'll have another intercept. And then halfway between the intercepts, you always have these mins and maxes. No matter what the curve is, those characteristics will still hold true because it's just like this repeating cycle. Okay? So see those like halfway patterns? Intercept, 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 halfway, maxes and mins. And that's dependent on if we have any reflections or what the amplitude is, and we'll factor all that in. So for now, for the basic sine curve, the max value is 1 and the min value is -1. We can label that on our graph. This would be like the max. This would be a min. Okay. One thing I want you to write down on your sine curve, right down here. The important kind of distinguisher is that it starts, the cycle starts at an x-intercept. When I was in college, I was like a teacher assistant, whatever you want to call it. I even forgot what we called them. SI, we called them SIs.
Really smart.
So that's, but anyway, why do they call them SIs? They call them supplemental instructors or something like that. But I was with a Precalc teacher, and he taught these like with like this cycle this way of like starting and ending, and I was like, oh my gosh, that's such a better way than how I learned it. So I'm gonna pass it on to you guys. It's gonna be really great. So you're getting college knowledge today.
Disgusting. God, you're a poet and you didn't even know it.
All right, cosine curve. We'll kind of breeze through this because it's very similar to sine. It's really just a sine curve that's shifted, or vice versa. You could say a cosine curve. You could say a sine curve is a cosine curve that's shifted over. Okay, so this one's our cosine curve. So same thing, count up by pi's over 4. You don't have to label all of them. Like you just want to do all the. Well, no, let's not be lazy.
I am lazy.
Let's not be lazy. Man, I'm just feeling refreshed and ready to grind today. This is great.
Speak for yourself.
I went on a 3.5 mile run this morning. I did.
3.5 miles.
Yep. I'm ready to go.
I went for a walk.
Did you shower after? Did you?
Of course.
Across the street.
I'll trust you. This.
Don't worry. And on your y-axis, count up by halves.
What time did you wake up this morning?
5:15.
2.
New Year's resolution, I'm going to work out before school.
That's.
Wait, what was your New Year's resolution?
I'm going to work out every day before
You know
school.
my last year's resolution?
Before this, I did it like.
What about your cheat day?
I just used to do a couple of cheat days. Nope, no more cheat days. I got to look good in my wedding dress. My wedding's only in 3 months, you guys.
Oh, so then after that, it's over.
Yeah.
I'm invited.
Fair enough.
Five,
That's
4,
a
and
question.
how
But I'm an adult. Just got the
It's
same
adults
amount.
only.
I am an adult.
About 600.
That's what I did for break. I did 0 school stuff, 100% wedding stuff. Books are shuttle. Picked out my wedding band.
Oh my god.
All right. Anyways,
Got my wedding done. Yeah. Oh my.
cosine curve. Here's the difference. So you guys, like I said, you're going to discover this all. But a cosine starts up here at 1. At pi, it's down here at -1. At 2 pi, it's back here at 1. And then halfway between these, so at pi over 2 and 3 pi over 2, it crosses the x-axis. Why? Question mark? Let's just take a quick look at the unit circle. Starting here at 0, what does cosine have a value of? 1. It starts up here to max.
30.
Right? At pi over 2, cosine is
0.
0. It crosses. Pi, it's at -1. Okay, remember you're plotting the values, the inputs are the angles. That's why it has this curve. And then it just repeats. Cross, min, cross, max. Cross, min, cross, max. And it's curvy. Make it curvy.
We got to make it curvy. She's got some.
What?
Are you assuming this curve's gender?
Yep.
Got Jackson.
2022.
It's 2022, Jackson.
I'm so sorry.
2022.
Okay, this one still has a midline.
It's a shan.
Okay. This one has a midline at y equals 0 also. It's always going to have a midline, not always at y equals 0. So it's going to have a midline though, because of the cycle, because of the cyclic piece of this. Domain and range. Domain is still all reals. Range, same reason as before. On my unit circle, could I ever have an x value? Could I ever have an x value on my unit circle less than -1? No. Could I ever have an x value in my unit circle greater than 1? No. So my range here is still -1 to 1. Now careful, because sometimes you're like, wait, x value, but you're talking about range. Remember, technically on the, once I make it a function, my inputs are the angles. My outputs are the cosine values. All right, so amplitude, same thing. Distance from the midline to a max. So this one also has an amplitude of 1. Now we can still think of this period from 0 to 2 pi, but it's just kind of starting at a different spot. It's like starting at a max. Well, watch what happens. It starts here up at a max, and then at 2 pi, it finishes, and you can almost think of like this is the piece that repeats. But that length, that period is still 2 pi. It just kind of starts at a different location, but I still want you to do this. Where it starts and ends. But my big difference here, how I kind of grasp whether I'm graphing a sine or cosine, is that cosine starts not at an x-intercept, but it kind of starts at like a maximum point. Yes, Max?
Is that why it's 2 pi still, and we don't do like the what we did with the other one and start it and then finish?
It would still be 2 pi. Like if you started it here at -pi over 2 and finished it at 3 pi over 2, what's that distance?
Oh, okay. It's just shifted over.
And that's what a cosine curve is. It's a sine curve that shifted over. That's all it is. Good question. But when you're graphing these, the easiest way to do it is to like just start it at a max, because then you can graph them all the same way every time by like setting up this little inequality. It'll tell you where to start and where to end it. But for cosine, you're just going to start up here and draw one cycle. This one has x-intercepts at -3 pi over 2, -pi over 2, pi over 2, 3 pi over 2. Why can I not call this multiples of pi over 2 though?
Because pi is pi over 2. It's just 2 pi over 2.
Exactly. These would all count. If I said multiples of pi over 2, that's counting them all. So any ideas of how I could say that? How could I differentiate?
Times 1 man.
Okay, close. Look at your numerators here. 3, -1.
Odd.
Odd multiples. Good. odd multiples of pi over 2. Odd multiples of pi over 2. And again, that just goes back to the unit circle. Here's the difference. The y-intercept is not 0. It's 1 because cosine starts at a max. But we still have a max value of 1 and a min of -1. You can label that if you want. This would be a max. This would be a min. Okay, cool. These are not that hard to graph because there's so many patterns. So once you kind of get down like the vocab and how to find the period, you're pretty much golden. Okay. Another way to think about amplitude, it's obviously like the distance from the midline to the max and min, but the midline is always going to be exactly in between the max and the min. That's what makes it a midline. Okay, so you can see here the average of 1 and -1 is what?
0.
0, right? So your textbook kind of defines amplitude as, well, it's half the distance between the max and the min, which that's the same. I mean, that's exactly the same. It's half of this distance. Okay, so however you want to think of it, that's the amplitude. Now, if I have some number out in front here, I better get decimals out here. Give you guys some decimals. Let's make some predictions.
Uh-oh.
What do you think is going to happen
It's gonna be curvy.
if I'm
It's going to be wider, skinnier.
okay, I like that. Can you be more specific?
Like the
Specific
range
with-
is gonna be
All
wider.
you said, if it's
Like what kind of transformation?
the
What else? You doing decimals?
watchers.
Okay.
Oh.
You can change your x-axis to be in terms of pi.
That's so
So here's
smart.
my sine curve.
Wow, this is
Right? You can see this
impressive.
goes on forever. 0 to 2 pi. Repeat 0 to 2 pi.
All right, if you increase that, it's gonna get wider. The range is gonna be big.
Okay, I like that. The range is gonna be different. It is gonna make it narrower
That
or
the midline's
wider.
gonna stay the same.
I'm trying to get what transformation? We have a number out
I
here.
know it's not good.
What kind of stretch or shrink? Vertical or horizontal?
Horizontal.
Stretch.
Bruh.
If it's outside,
Vertical.
vertical.
Wow.
Vertical stretch or shrink.
Let's go.
Right? So let's say A is 4.
Look at that midline though. It stayed the same.
Midline stays the same. Does the period change?
No.
The length of one cycle? Nope, it's still 2
No.
pi. What's the only thing that's changing?
Min-max.
The min-max and the amplitude.
Yeah.
Good. So whatever that vertical stretch or shrink factor is, guys, whatever that A is, that's just your amplitude. Now I'm going to put absolute value bars around this, and I'll explain why. And Max kind of actually already discovered this. What would happen if that A was negative? It's going to reflect, yep. So if A is negative, you remember which axis?
Is that X1?
Yep.
What?
Did I spell reflection wrong? Yeah, I did. Oops.
Mine, I can't spell it. Look at my vocab test.
Reflection over the x-axis. Okay, so I'll show you that on decimals. Now, that doesn't change the amplitude. So right now the amplitude's 2. So here's my midline. So again, you can think your amplitude as, I like to think of it as this distance, from the midline to a max. It's also like half this distance, right? From a min to a max. That's what your book says. From 2 to -2, it's half that distance. If I make it a -2, my amplitude is still 2. My amplitude is still 2, but now just kind of like the shape of the curve. And yeah, if there's a reflection, we're just gonna have to go down and up. Okay, so if you have a number out in front there, that number right there, it's nice that they use the letter A. It doesn't stand for amplitude. You can think of it that way. They just use the first letter in the alphabet. It's A, because now we're gonna do ones with B in a second here. But if you want to make, I mean, you can. If there's a number in front there, that's gonna change your amplitude. Okay. Now let's do if we have a horizontal stretch or shrink factor. And that means I'm multiplying by a number inside, or like just with the x. Remember, high, low, horizontal, inside. So if I have some b here, let's do the same letters. Horizontal stretch or shrink, I kind of take the ends of the curve and do like this way. So now this
Whoa.
changes what?
Yeah, that's pretty neat.
No.
It changes period.
Changes the period. It changes the length of one
You
cycle.
are.
It doesn't change the amplitude, right?
No.
Doesn't change the amplitude.
Oh.
So, these ones are always backwards from what you think. So when that number is big, it's actually a horizontal shrink, right?
And that period is smaller.
And when that number's small,
It's really big.
it's a horizontal stretch. It makes it really wide. So to find the period, I want you to write this down in your notes, but I'm going to show you an easier way to do it. But the period is always going to be, since it starts at 2 pi, normally, you're just going to take 2 pi and you're going to divide it by whatever that b factor is. Okay, and the reason why we have to divide it is because we kind of have to like do the opposite to apply like the horizontal transformation. So your period is just 2 pi divided by whatever that stretch or shrink factor is. Okay, so let's look at this one for example. Let me zoom out here. I know it's hard to see.
What if the b is negative?
Then it reflects it over
This is
the y-axis. Good question. So now this one starts at 0. Where does it look like it ends?
What is that?
5 pi, right?
5 pi, yeah, I do that.
Oh, I did 0.4. Hold on. Let's do 0.5. So that's a little bit nicer number. Okay, sorry. Let's do this. Starts here, ends where?
6 pi.
4 pi.
4 pi. Yep. So here's one cycle. There's one cycle,
Just what?
and then it repeats. I'm trying to click on 4 pi. There we go. And then it just repeats from there. So in this case, my period is 2 pi divided by b is 1/2 would give me 4 pi, and that's your new period. That's the length of one cycle. That's how you can find your period.
This is like magic.
2 pi divided by b. B's 1/2 for this example, okay? Now, I'm going to show you an easier way to do that, but we will use that formula when we write equations for sine and cosine curves, so we do need to know that your period is 2 pi divided by whatever that b factor is. Let's take it one step further.
Another
Oh, what?
You know I'm not smart
Okay.
enough for this.
So, you can do it. Let's write down what we already know.
Wasn't there
So,
winter break yesterday.
A is our amplitude, but what it really is, it's a vertical stretch or shrink. So I know that the absolute value of that is the amplitude. Height from min to max, if you want to write that down. If you know what the amplitude is, you don't have to. If A is negative, that's a reflection. Okay, so we just looked at that on decimals. Then we looked at horizontal stretches and shrinks. That's what B is. So B and C kind of go hand in hand because they both affect your period. So B, technically the transformation, horizontal stretch or shrink, depending on what the number is. So do you guys remember transformation-wise what that like C would do if you add or subtract the number like inside?
Doesn't it shift it?
Right or left? Yep, shifts it right or left. Good. So horizontal
Good at this.
shift left or right. So both of these are going to affect the period. The horizontal stretch or shrink will affect like the actual length of the period, and then the shift, we call it like a phase shift, is going to determine now where it starts and where it ends. Okay. So let me show you this on decimals quick. Let's get rid of B. Let's just do like C just for a second. So in parentheses, B, where are my parentheses? X plus some C. Okay, so right now it's going to add 1 right away. Okay, so let's say add nothing. So here's my sine curve. Starts here, ends here. So if I add something, it's shifting it to the left, right? Now, there's more than, I mean, you could also call it like a shift right because it's periodic. And that's what I'm saying, like a sine curve. There's my cosine curve now. Starts here, ends here. A sine and a cosine curve is just, it shifted. Now if C is negative, shifts it to the right. So it doesn't change like the period, the length of a cycle. That would be if I have some number right here, like 2. But it does change where I kind of start and end my cycle. Okay. So these two go hand in hand in changing your period. So what I want you to write in your notes is this inequality. You're going to take whatever, and this works the same for cosine too. I'm just showing you sine as an example. You're going to take whatever's in there and you're going to set it up in this inequality. You're going to solve for x. We're not going to do it with letters, but we're going to do this with numbers. And this tells you 2 things. It tells you where to start your curve, where to end it, and it tells you the period. So this right here is going to give you the period. Which is the length. Oh my gosh. I'm just going to go full screen here. What am I doing? I think my shirt hits the smartboard. It has these frilly things. Length of one cycle. Okay, and then the last factor, the last transformation here is if I have a plus or minus, for that matter, a number kind of like outside. Do you guys remember that transformation?
Up.
Vertical, shift, up or down. Good. What do you think that's going to change?
Min-max.
Yes, it will change the min and max.
Midline.
The midline. Good. The midline. Let's take a look. Let's get rid of this. Let's get rid of this. Let's get rid of this. Sorry, I'll flip back if you didn't get that all written down. Let's go plus some D value. So it's going to start off with 1. If I shift it up 1, now my midline's here. Did it change the amplitude? No.
No.
That distance is still 1. It just shifts it up or down. Good. Okay. So y equals D. If it's a shift up or down, that's going to be your new midline. Which is the horizontal line through middle of curve. Okay, that's a great stopping point. Tomorrow we'll actually practice finding amplitude and period and then also graphing some, which is so fun. Thanks for joining me today on our first day back in 2022. What a nice day. This is going to be our last new thing.
Wow.